Давайте, поехали. Hello, everyone. My name is Vladimir, and welcome back to the Architecture Weekly YouTube channel. Well, today we're having a mock system design interview. So basically, I will be giving out a task that you would probably encounter in some of the system design interviews. And my colleague will be trying to solve that task, and we will demonstrate it live. The person who will be doing is Igor Bondarenko. Igor, please welcome.
Yes, hello, my name is Igor. I work and live in the Netherlands. I work as a software developer at an eco company, which is energy company. Thank you for having me today.
Yeah, cool. So for if you like the content, don't forget to subscribe to the channel. You can always leave a comment with the questions about the task or about the designing process and so on. And if you want to be part of the discussion, want to join the meeting live, you can subscribe to the Patreon or Boosty. And for followers on those platforms, you will get the access to the actual Zoom call. Okay, so without further ado, let's start the task. So let's have the task definition. So today we're trying to design the video portal. So basically something like a easy version of the YouTube, right? So the author can upload a video in a MOV format. The video will have a title, a description, and a thumbnail. Then each video should have a unique URL, and viewers should be able to see this video on the web and the mobile devices run by Android and iOS. So the video will also have the subtitles in different languages, and we can rewind the stream back or fast forward. So yeah, that's the initial requirements. I will drop them in the chat, and let's go.
Yes, thank you. I will share my screen.
Sure.
Okay. Yeah. So I will quickly recap what we do. So we are doing video portal YouTube we will have ability to upload video. Video will contain title. What else? What was it? Could you repeat, Vladimir?
Title, description, and the thumbnail.
Yeah, description and thumbnail. Okay. Then a user should be able to watch video. Okay, watch video from different devices. We will say mobile, browser. Yes. And we should be able to have subtitles on different languages. Yes.
Yeah, correct.
Okay, cool. Okay, so let me start from clarifying our scope. We don't want to have any additional functionality from YouTube like likes, comments. We only concentrate on uploading and viewing the video. Am I right?
Let's have this as a stretch goal, right? So maybe we can add the comments or likes later, but we need to focus on the core task.
Okay. Could you please tell me the daily active users of our portal?
Okay, let's try to see this. So we're targeting 100 million people per year. So it's roughly 8 millions per month.
Mm-hmm. Okay. So this is the users who, okay, this all users of our portal.
Yep.
Yeah. May I assume that 10% of these users will upload videos?
Well, it's not 10% because typically the number of authors is much less. So let's target 100,000 authors.
Okay, let's make it 100,000 authors. Okay, so may I say that a regular video will be around 10 10 minutes, and
Okay.
which will lead to probably 40 megabytes, 50, 100. Depend on quality. Let's make it.
Well, we need to talk about the domain here. Like, how do you think the video is structured for this kind of websites?
Yeah, so we have a video. I'm talking right now about source video. Of course, in the end, we will have encoders who will encode this video to different resolutions to satisfy different needs of our users. But for now, I just need to estimate throughput kind of our system. Yeah.
Okay. Well, if we're talking like a full HD or 4K video, it will be pretty big. So 10 minutes will be, I don't know, like several gigabytes.
Yeah. Let's make it 1 gigabyte for sake of simplicity.
Okay.
Now. Yes. Okay. So we have authors, 1 million. Okay. 8 millions per month. Okay. So let's calculate probably what we have per day. So it will be divided by 32. So we can make it 300,000 per day, which will give us around. Okay. So am I right? Yes.
What is 32?
It's a number of days. Let's make it 30 then.
Per month?
Yeah,
okay.
Yeah. Okay, so it will be around, if we make it 9 millions here, it will be around 300,000 per day.
Okay.
And if we have 10 power 5 seconds in a day, then yeah, it's not that much. It will be around 3 per second.
3 videos per second?
3. No, it's a number of active users.
Oh, okay.
Second. Yeah.
Okay.
Okay. Cool. So yeah, to estimate, so we have 100,000 authors, and they have they load some videos like 1 gigabyte, and then we should estimate how many videos they can load per month. I believe it can be around 10.
Okay, we can go with 10 videos. My initial idea was at least 1 video weekly, but like 10 videos per month, it's like 2.5 videos weekly. So yeah, okay.
Yeah, something like that. So in this case, we have 100,000 authors multiplied by 10 videos and multiplied by 1 gigabyte. It will be around 1 million gigabyte per month, which is not that much. It will be 1 petabyte, if I'm not mistaken.
Okay.
Yeah, per month.
Per month. Yeah.
Okay, so then we can think that our video portal would like to last at least 5 years. And we can estimate approximately how much storage we need. In this case, it will be 5 multiplied by 12 multiplied by 1 petabyte. So it will be 60 petabytes. Okay. So probably we need. I need to ask you about availability. So do we need, what kind of availability do we expect from this system?
Well, let's have 3 nines of availability. I mean, if somebody cannot see, no, what you have here is 5 nines. I'm
sorry.
Speaking
yes,
about,
yes.
Speaking about 3. So like if somebody at night cannot watch a video, like not a big deal, I believe.
Yes, is that okay? And what kind of budget do we have? So this is a question related to how much CDN can we use, and yeah. So is it kind of unlimited budget?
Well, let's try to estimate. If we have the audience of 100 million people per month,
Yeah.
right? I think we're talking about
per year.
I don't know. Yeah, per year. I think we're talking about I don't know, at least 10 million of euro budget per year. Yeah.
Yeah.
So yeah, I think that's a reasonable thing.
Okay. Okay. Yeah. Cool. So let me start with the high-level design, and of course, let's talk about security. So I expect.
Okay.
Yeah, I expect that we want to encode our videos on the servers because it can be some sensitive information.
Videos are not sensitive information from, I don't know, PII or PHI.
Yeah, not for PII, but for people, yeah, it's probably important to, if you want to hide a video, then it's better to encode it.
And do you mean encrypt or encode?
Yeah, sorry, yeah, encrypt. Yes, encrypt. Yeah.
Well, yeah, okay. I believe that would be a little bit expensive, but okay.
Okay, we can eliminate it, but we should at least you also told that when we upload a video, we should have a unique URL for this video, and if we share this unique URL, so we should probably think that we should have some at least a token to understand who can watch this video.
Yeah, definitely. So because videos can be private or unlisted or public, right?
Yeah.
So this is kind of an essential functionality, because when I upload a video, I want to make it unlisted at least, to see like how it goes, test it maybe with the closed groups of followers, etc., and only then make it public.
Yes, exactly. Okay. Let's start with some high-level design. So we have generally two flows, but let's start with just a regular flow. So we have a user, and we can make it as a mobile, desktop. Okay, well, let's make it beautiful. Okay, so we have some gateway for now.
Let's zoom in a little bit.
Yes. Sorry. This gateway. And we have some upload service, and let's say some video service. Let's call it watch service for now. Okay, so then we have definitely some database to have our videos. So it can be object storage. I will make it quite simple for now. Okay. Yeah. And it's wrong. Okay, yeah, sorry. Yeah. So, and we have some database for metadata as well. We can have it document database. We will call it metadata DB. We also can have something for users. Okay. And we will create a user service. Okay, so let's make it simple. So for now, we have our two clients, and we are going to look at if you want to upload video, then we definitely need to save some metadata about video. We also need to check can we upload this video, and what account do we need. Then if we want to watch video, then we can ask from metadata database about location of this video on our blob storage, let's say, and come to blob storage to get this video. So this is a super simple high-level design. Yeah, so here on gateway, we can do some authorization, and on user service, we can check some information about user, its privileges, grants, access, and yeah.
Yeah, then we need an arrow from gateway to the user service.
Yes. Yes. So for my high-level design, yeah. So generally we have two flows, and for now, I see it like this. I will call it users.
Okay, so two flows are uploading a video.
Yes.
And then watching a video.
Yes. Let me check. Yeah. So yeah, for high-level design, we can think about it. Of course, we haven't touched some of the requirements, but let's go into deep dive section right now.
Okay.
Yeah. So first of all, let's talk about how do we upload videos. I will go here. So let's say we have again user. We have some uploader service. So basically, when we want to upload a video, we want to have some different resolutions for different clients. Let's say for mobile, we need less resolution. For web application, we can go with 4K, whatever. So we have encoders. Our uploader can create some chunks of the video and put it into encoders. And also we have two databases here. So object database and database for metadata. So let's say we started to upload our video. We can say, okay, let's put it into metadata database to say that we started. Then we can have a service which can get our, let's make it like this for now, which can make, we can call it chunker. Now it's uploader can chunk it for us. Let's have a service which will prepare our, let's call it splitter. Okay. So we split the video.
What it's gonna do?
So it will split the video into small chunks, and first uploader will upload the video to object storage as is, and then we will split the video into small chunks, and then we will have different types of tasks. So let's say we have here encoders to split video into different resolutions. Let's say we have also audio encoder. So we can have multiple tasks here. So video encoders. We can have video encoders. We can have also task to prepare our subtitles. So whatever we want, and we also need our metadata database here. Let's make it here. So we can also talk with metadata database when we finish to encode our audio video. So definitely we are talking about a cyclic graph here. So we can have multiple tasks and then we split these tasks into different workers. And these workers pick this task, does the job for encoding video, audio, adding some watermark, thumbnail, whatever. And here, as a communication, we can have a message queue.
Okay, nice. I
Yes.
wanted to ask the next question. Okay,
yes,
cool.
So we will have a message queue as a communication. So in general, we will have a lot of tasks, and usually we call it a group of pictures or screen is a GOP. We can split the video on GOPs. We can parallelize it by encoding video and audio separately. And in metadata, we have our data about chunks, and we don't encode video or audio as a one piece. We split it, and that's how we can increase parallelism. And also we increase our availability, since we don't need to start it all over again. If something is dropped, we can just continue with a small task and don't repeat ourselves too much. So do you want to go deeper with this?
So the first question here is, like, imagine you fail to either write the data to the metadata database or to object storage. How do you handle this situation?
So in this case, here as well, I can try to add message queues here to say I have a service, metadata service here. And uploader will send a message to message queue, and then metadata service will eventually send data to metadata. If I fail to upload my file from the beginning to object storage, then user should try it again, because this is the full file, and we don't have a client from user. So it's if you upload a video from browser, you cannot chunk it already, so it will be chunked here in Splitter.
The question here is, do we have any technologies that could help to resume the uploading of the file? So like we're speaking about pretty big files, like gigabytes, right? And if we upload like the half of them, it's kind of unfortunate to start it all over. Can we do something about that?
If you upload it from the browser? So I believe that we still can upload it by pieces. So if I'm not mistaken, some protocols will help us to do this. Usually we can split it, and when we upload one part, we can continue from another part, and usually we have some e-text or something to continue.
Well, the trick here is that HTTP protocol supports the content range thing. So we can say like, hey, I'm uploading this bit of the file, so just add it there, and the server should be able to handle it gracefully.
Yes. So
okay.
In this case, we can just upload it partially and continue with it.
Okay.
So here we still can have another message queue and service from our uploader, and then make it
Yeah, so but basically uploader won't speak directly to the splitter. It will post a message to the topic saying like, hey, the video is uploaded, like start processing, right?
Yeah. Okay. Yeah.
Yeah. And another question is like, if you have ever uploaded a video to the YouTube, which I'm doing like pretty frequently, you would see that like once the video is fully uploaded, it starts processing and you see that in the user interface. So somehow the web application sees that the status of the uploading changed. So we need to account for that as well.
Yeah, so let's say Splitter received these chunks of data from video, and then we can, from message queue, let's say video encoders encode video and save it to the object storage. We can even make it like this. So let's say it's from Splitter, and then Splitter can give some back communication to the video service to say that, okay, this part was uploaded, and then video service can communicate with the client and say that, look, we moved to another part.
Okay. So like we have the bidirectional relationship with the queue, right? So we're posting the messages from the video service to the different topics in queues, and getting the messages back in order to communicate the change to the user. What technology would you use to get the messages back to the user interface, or you will make the browser poll the video for the status updates?
So here we can use different technology. So first we can think about WebSockets, but actually I'm not sure how fast it will be. We can have a long polling as well to wait until one part of the video is uploaded and then have a callback from the server to client. But I would say it's not that important, since we are not on online game or something. We can use both WebSockets or long polling.
How does the perspective of uploading the videos from the mobile phones changes the solution?
Yeah, so from the mobile phone, we probably should have a client, like an application. Am I right? Yeah. So in this case, yeah. So actually, will it change it?
Yeah. Wait, what are the main considerations when we're talking about the mobile applications?
Yeah. In this case, to notify the client back about some successful uploaded videos, we should notify it not directly, but through the here we don't need here push notification.
No, we definitely don't.
Yeah. So yeah, mobile client can split the video itself and try to send.
Are you sure? Like it's uploading the same video 4 times.
4 times?
Yeah. Well, if you rely on the mobile application to split the video into the different chunks.
No.
And process it, or you mean a different thing?
No. I mean, so we still upload the video from the client, not from the browser, and we still can upload it by chunks. Now, not itself. Mobile application will do it. It's still via the protocol. But what will be the difference in this case? So probably the connection is much smaller, and yeah,
probably. Yeah. So with mobile phones, you typically have 2 problems: the bandwidth, right?
Yes.
And the quality of the mobile internet, and the battery life.
Yes. So since we don't do any job on mobile phone except just sending the information, yeah, we should be able to recover, but we are able to recover also for web browser. I don't see the big difference here, except that maybe we will use another protocol.
Okay, well, I suppose we'll use the same protocol just for the sake not doing the same thing twice. But Konstantin is asking, like, what are the cons and pros of each approach? I mean, long polling or having WebSockets or anything else?
Yeah, so for WebSockets, our video service, maybe not our video service, but some other service would be not stateless, but stateful, which is a little bit more difficult to scale it horizontally. For long polling, we will keep a connection until video service would have something to return back to the user. Actually, WebSockets are good when we have bidirectional communication quite often, but here, if our chunks, let's say, to upload our chunk of video will, maybe will remain a second or something, then I believe long polling can be a way to go. So why not?
Okay.
This is only about status. Yes.
Yeah. We have another a couple of messages from Nikita in the chat.
Yeah.
So there are some problems with bidirectional communications via queues or topics. For instance, routing the client's messages back to the original producer, which leads to either over-consuming the data or complex data routing based on keys in terms of Kafka. Like I'm not very agree, but what would you say?
Yeah, I don't think that this is a huge problem. Actually, yeah. But can you repeat the question again? So what was the exact problem?
Like the problem was routing the client's messages back to the original producer. I think Nikita is means that like you submitted a message to, I don't know, to Splitter through the queue, right? You want to wait for the Splitter to notify the video uploader that, hey, like splitting is completed, right? So that we can communicate status back to the user. And it's like you need to know that the information about a particular video corresponds to a particular user to send a notification back.
Yeah. Yeah, I don't agree with it. It's not a huge problem, since you can have you can so for Kafka, you have this partition key and partition groups, let's say. So I don't think that it's a big problem if we listen for the same. Let's say we have our video with some key, and then when we communicate it back, the same split and the same, let's say, video service will listen to this topic mostly. So if you make it right, the consumer and the producer can share the same key, and then it's not difficult to route it to the right service. I don't see a problem here.
Okay. Yeah. Let's go further and think about how we're gonna scale this.
Yeah, how we're gonna scale this. So let's talk about object storage. So for object storage, we can use Amazon S3 or Azure Blob Storage, and it will be quite costly, but at the same time we have high availability. We have data replication and a lot of things out of the box. If we want to save some space, we can use Erasure coding here to decrease amount of data we need to store to recover from a data loss or disaster. For metadata database, we can use wherever we want, key value or columnar. Let's say we use Cassandra here. Cassandra is highly available, and it's easy to scale as well. If we use Cassandra as a cloud service, it's not difficult to scale it. Then splitter, we don't have only one splitter, but we have many splitters here. So
it's a splitter cluster, right?
Yeah.
So
yes.
Those are basically worker nodes, right? That they are stateless, more or less.
This is workers, and here video encoders and video and audio encoders are workers as well. So we have many of them as well. So we can scale them as much as we want. So it's not a problem. So when we have this,
there's one note here. Like when we say it's not a problem, we need to explain what we're gonna do if a particular part, a particular splitter working on some video crashes, right?
Yeah.
Like out of memory or something else. Like we need to understand that some chunks of the video were not processed and restart the job. Like how we're gonna achieve that?
Yeah. So we have our message queue, and let's say we have quite amount of splitters, and when we take a message from message queue, if it's if we cannot route it further to the system, then we will not move our offset, let's say for Kafka, and then in case of any trouble, let's say a splitter dies, another splitter can join, and broker will assign the same partition to this new splitter, and this new splitter will continue with the offset from previous splitter, which was not shifted because of splitter didn't get an acknowledgement for the processing. So
okay, got it.
Yes. So we are quite good horizontally scalable here, so we don't have any kind of big bottlenecks here. So message queues like Kafka or any other like event grid from Asia is we can scale it horizontally, and this is not a problem as well, especially if it's still managed by cloud or ourselves. Should we look at read flow?
Let's go to the read flow, but we will have to get back because we mentioned we want some security and encryption for the videos. And that brings a problem of key management, and all that stuff.
Okay, let's first go to the read flow, and then we can continue with this. So for read flow, we have our user come into our system again. Video. We have this gateway. I don't want to repeat the whole system, which I drew from the beginning. But let's say we have something, video, and we still have our storage here. So here the main part will be that we are not always go to our system to retrieve the video, and we can use CDN. Do I have CDN? No, I don't have CDN here. Okay. We will use CDN mostly to retrieve our videos. So the question, how can we restrict access to our CDN if user is not allowed to do this? So we will mostly generate URLs with some token, and CDN can handle this on its own to restrict access. And of course, we don't send the whole video at once for our user. We will send it partially. So when, let's say on YouTube, you want to change the your current position on the video, let's say from 1 minute to 1 hour, 1 minute. Of course, you will not load all the stuff till 1 hour, 1 minute. You will have to load only some separate chunk for 1 hour, 1 minute. So actually,
how that's achievable? So what
if I'm not mistaken,
data formats will help you do that.
Yeah, if I'm not mistaken, we will have when we request for the video, the protocol can help us to achieve it. The answer from the service would be, if I'm not mistaken, some data structure where we can have different parts of the video with different. I'm not sure. Yeah, probably.
Well, with the modern containers,
Yes.
MPEG containers, if I'm not mistaken, you will have the links to different parts of the video, like different qualities of the video, right? That will have both qualities, and another link with the file with the subtitles.
Yes, it will be, and in audio as well can be in this container separately.
Yeah.
I know that Matroska as well is supported.
Yeah, exactly.
Yes.
Matroska container. Also for the video itself, HLS I think supports streaming this file, right, and picking up the chunks of the file that you want to look at, not downloading the whole video at once.
Yes, of course. So the simple answer will be the protocol will help us to load only what we need and the quality what we need. And since modern containers support separation of video, audio, and subtitles, we can dynamically change it, which is not a problem as well.
Okay.
Yes. So here we can talk about user and database for so metadata database and user database. And on metadata database, we store information about parts of the video in our S3 storage, let's say, and in user database, we have all the information about user and I don't know, videos, permissions for these videos. Permissions for these videos will be in metadata database. So say we have it like this. Then user have the data. Yeah. So let me check. Yeah, so here we will have title, description, and some information about blob storage, where it's placed on blob storage. We will have some hashes as well. Maybe, yeah, we would like to reduce the duplicates as well. Subtitles can be handled on object storage as well. And it will be linked to video metadata. What kind of subtitles do we have? Yeah.
Okay.
Yes. So if we want to have some cache here and there, so for user data, we can have some cache for metadata of the video. Is good to have cache. Let's say we have some popular videos, and we want to cache some data. Same as for user. For our scale, it can be useful. Let's say using Pareto rule, we can only cache 20% what we need.
Yeah, so basically the flow looks like the user connects to the gateway requests the video, then the video service checks the permissions of that particular user and video, right?
Yes.
And then, like, if it's allowed, then requests the metadata. So basically where the video is located, what is the title, blah 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 blah, and then responds with the link to the container, basically.
Yes, and then your user can load this video, start loading this video.
Okay, cool.
Yes.
Let's try to design the API for the read and write cases.
Okay. So for let's say for upload, so we need some data from the user. Let's say it will be title of the video. Then we need a description. Then we also need a token, user token, so understand who is talking to us. Yes. Then we also can have, let me check. So what do we have in the requirements? Thumbnail, the video title, a browser. Yes. So we have title, description, user token. So here we are talking about our initial request to start uploading video. Yes. Okay. So yeah. User token. We can also have some. But we can put all the information in the token we needed.
Yeah, the image for the thumbnail.
Yeah. Thumbnail image. Yeah. Yeah, and then we can start uploading it piece by piece. So it's okay. So should we go to read flow then?
Yeah, let's go.
Does make sense. Okay. So for it, we have again user token. Then we have URL of the video, and yeah. So mostly that's it. And here we can expect that for upload, yeah, we'll have back information about our progress, but this can be done not from the initial request. So for it, yeah, URL token, URL video. Yeah, I think that we can receive all the information by URL.
Okay. Okay, cool.
Yeah.
Let's get back a little bit. So what's the database we're using for the metadata storage?
Yeah, as I told you, we can use Cassandra here. We don't really yeah, we don't really need any kind of restrictions here about ACID properties. So it's still doable with Cassandra. And on Cassandra, you can, of course, tune the consistency level and replication level. Yeah.
What are the alternatives here?
What are the alternatives? Yeah, we can use MongoDB as well, because usually videos has information about its own and is not crossing between other videos. So Mongo as a document storage can be used here as well.
If you could compare the Cassandra and Mongo options, what will be the pros and cons of both solutions?
So for Cassandra, we can have yeah. So what is the biggest difference? That for Cassandra is mostly easier to scale, and we have more options to filter some data and aggregate some data. For MongoDB, for newer versions, we have transactions. We have ability to build some indexes over fields, but generally, if you need to update something frequently, then I would go with Cassandra than Mongo, because for Mongo it's difficult to update some particular fields in the document.
Okay, anything else like the scalability for both options?
Yeah, so for Mongo, if we build a Mongo cluster, then we have just a hash function to split our data into different Mongo servers. For Cassandra, we again have consistent hashing and ability to add as many nodes as we need, and we don't have master here for Cassandra. All nodes are all sufficient. Yeah, I believe in terms of
Can you briefly explain what is the consistent hashing and what problems does it solve?
Yes, of course. So consistent hashing, we can imagine that we have some ring. On this ring, we can place, I don't know, let's make it like this, numbers from 1 to 256. And then we have, let's say for Cassandra, we have servers here. And we can have physical servers, we can have virtual nodes. So if, let's say, from the beginning, imagine we have only physical servers. Then we have a request. We use hash function to understand where this request should belong. Let's say it's here. Then we go clockwise to the nearest server, and we can retrieve the necessary data from this server. So for Cassandra, of course, it's not working like this. We go to any servers, and it's move it us to the right server. But we can imagine it like this. So what is good about it is if you use a regular hash function, let's say, I don't know, remainder of division of 4, then if we rebalance and if we add node or remove node, we should remap a lot of keys, a lot of data. But for consistent hashing, we don't need to do this because usually we replicate it to the furthest nodes, and adding or removing a node will only affect not big amount of data. And adding virtual nodes even helps this problem. We can not only look at physical servers, but create virtual servers.
So, that's pretty cool.
Yeah, it will be n divided by key, where is key is a number of our servers. Yeah.
Okay. The next question is that how do you do service discovery with consistent hashing?
Yeah, so usually we have a gossip protocol, and we can have knowledge about other servers on our node. So we check their health, and then we split this information about health of our servers between all our servers. And then if we consider that server is dead, we can start excluding it. So usually we're using gossip protocol for this.
Okay, any gossip alternatives?
Any alternatives for this? Yeah, so we can have something like Zookeeper, and keep it in Zookeeper and update the data about availability of our servers. If we talk about let's say another way instead of gossip protocol, we can every server can ask every server as well, which is not that efficient as gossip protocol. Or we can have a coordination node which will ask for health and then save it somewhere in Zookeeper as well. So many different options.
But that means that you need to monitor for this, this leading node and replace it.
Yes, and then we should have shadow node for this node. Yeah, so this is much more inconvenient.
Yeah. Okay. Let's get back to the list of the requirements and see if we missed anything. So subtitles we discussed. Unique URL. Yeah, let's talk about the unique URL. How are you going to generate those? Yeah,
so for unique URLs, it's a additional topic. So what we can do, we can have key generation service with predefined unique URLs. No, not unique URLs itself, but let's say we have I don't know, some kind of places, some kind of number of characters, and we can generate randomly all of these characters, put it in some database, and then when we need a unique URL, we can take it from this TJS service.
Okay, looks like you knew the answer.
Yeah, I mean,
you just got straight ahead through all the caveats that I wanted to ask. Okay, let's calculate the number of characters that we need for the short URL for our amount of videos.
Yeah, so then we should go back to our calculations. Okay, so how many videos do we have? We have 10 videos per month. Okay, let's make it again. Like, so we have 100,000 authors, 10 videos per month, and we have 12 months for 5 years. Yes, so it will be not a big number, definitely. So it will be 60 millions, if I'm not mistaken, which is not a lot.
60. Okay.
Yeah. So then for 60 millions, we can have a different bases for it. Let's say we use base 64. It will be difficult for me to check what power of 64 we need to use to gain 60 millions, but I believe it will be around 4.
Well, 1 to power of 10 is roughly 1,000. 2 to power of 20 is 1,000,000, roughly, again.
Yeah.
So it will be 2 to the power 26, if I calculate correctly. And 64 is 2 to the power of 6. So it's like, yeah, I would believe 64 to the power of 5 would do the trick.
Of 5, yeah, of 5 will do the trick, because I know of power of 7, it will be couple of trillions, like 3 trillion, and
okay,
and the power of 6 is probably 60 billions. I'm not sure, but let it be like this. Yeah, so then we need 5 places with a 64 base in this case.
Okay, so basically those like 5 characters, lower and upper.
Yeah. So it will be
letters and numbers.
Yes, and for
cool.
64, it will be also probably some symbols as well.
Yeah, super cool.
Yes.
Okay, so we have another comment in the chat. Like Nikita tells us again that I would say that I'm against the gateway terminating authorization for video service.
Okay.
Due to the traffic duplication between services to transfer the video response, binary data, back through the gateway. Like, how can we address that?
Yeah, so when gateway sends the link, let's say to, is it about uploading or downloading?
I think that's about downloading.
Downloading the video. So when we watch the video. Yeah, so we can go straight to the CDN, or we can go straight to the watch service instead of gateway. So after we got the link with token, I mean, we can bypass gateway if it's such a huge problem. Usually for such systems, we have a lot of items in between, like reverse proxies and so on and so forth. It's not that simple that just deleting gateway, it will solve the problem.
Yeah, I thought maybe redirecting to some URLs or something like that. But yeah, like Nikita is saying, like that we can use some libraries or tools to bypass the traffic with zero overhead. So yeah, definitely worth looking into those kind of solutions, because traffic with such volumes can be expensive.
Yes.
So
exactly.
yeah. Okay, cool. So we're 1 hour in. Like, thank you very much.
Thank you.
What are your impressions of the task, and how did you manage that?
Yeah, I think it went quite well. The topic was familiar to me. Maybe I can better describe upload flow, because here we have we can have tasks with let's say task schedulers. We can have something with graph acyclic. Then we can here we have a lot of stuff. Maybe we can talk more about erasure coding for videos. Maybe we can talk about resolutions more, but definitely it was not bad. Here we talked about CDN, different databases, KGS. Yeah, I think it went not bad, at least.
Yeah, I would say that like you definitely passed the interview as a senior plus, so that was really cool. You were, you knew a lot of stuff, explained the difficult things, predicted the things where with the splitting and communicating back, and explained the consistent hash properly. So that was great. Thank you very much. I think I will try to use that as an example of a system design interview. And yeah, like folks, like if you need some trainings, like if you're afraid of a system design interview and you need some, private consultations or mock system designs in private, so my contacts will be down below under the description of this video. And if you like such of the content, consider to help it at Patreon or Boosty. Like, yeah, thank you very much. See ya next week, because on Monday we have a video about the introduction to the Kubernetes with Carlos Sanchez from Adobe. So yeah, see ya next time. Thank you very much. Bye-bye.
Thank you.